Hi, Assalamualaikum everyone, and to Dr. Azazi. I am Haikal Zarif, representing my Group 6, to present on our study about eddy current testing. This is the layout of our presentation. Okay, this is the fundamental of the eddy current testing. Okay, basically, this section will brief shortly about the background of the ECT. Okay. Eddy current is the one of the most widely used NDT, non-destructive testing technique in industry today, and this technique uh, contain various reliable quantities such as non-contact, rapid inspection speed, and high sensitivity to surface detect compared to the other NDT such as ultrasonic and magnetic flux leakage testing. Okay, basically ECT is applied to discover flaw and to perform measurements, um, especially in small region. Perform measurement meaning that to measure the thickness of the specimen. Okay, back to the history of ECT. The eddy current phenomenon is discovered by the French physicist, which is Leon Foucault in 1851. This is why we also call eddy current as Foucault current. Okay, eddy current testing uh, begin as Michael Faraday, who is the responsible person to discover the electromagnetic induction in 1831. This is Michael Faraday. Okay. Okay. He discovered that when a magnetic field passes through a conductor or a material which have electron can move easily, or a conductor passes through a magnetic field, an electric current will flow through the conductor if there is a closed path through which the current can circulate. Okay. In 1879, another breakthrough was made when another English scientist, which is David Hughes, demonstrated how the properties of a coil change when placed in contact with metal of different conductivity and permeability. Next, let's dive into the theory of the ECT. Okay, first, the working principle. Eddy current inspection apply the principle of electromagnetism as the basis of conducting examinations. When the alternating current supply, magnetic field develop in and around in a conductor such as copper wire. Okay, when AC increases, the magnetic field expand. Okay, as you can see here in the copper wire here, there is a magnetic field exists when the AC is applied. As the AC increases, the magnetic field will expand more, will expand bigger. Okay, and the eddy current establish secondary field which oppose the primary fields. In this ECT, okay, this is the the magnetic field I explained before appear at here as the primary fields, and this is the conductor that said to be the secondary field appear here. Okay, and defect in the test specimen affect the induced field, thus change net flux in linkage and net impedance of the coil. Okay, as we can see in this picture here, okay, this is the condition. Let's look at the secondary field here. This is the normal condition where the specimen does not contain any abnormalities. Okay, this is how the this is how the specimen that contain defect, and the defect change the induced field and change the flux linkage, also change the impedance of the coil. Okay, as you can see here, the uh, the secondary field is not in the uniform shape. Okay, that indicate the defect in the specimen. Next, okay, here are the important properties that we need to consider in ECT. First one is the properties of the test specimen. We need to make sure that the specimen is electrical conductive. The dimension, such as depth of conducting plate, must be in the range of the ECT. Okay, the specimen must be magnetic permeability, meaning that the measure of magnetization that a material obtains. Okay, and the last one for test specimen is the material discontinuities or defect. Okay, such as crack or corrosion. Okay, for the instrument properties, the frequency of current excitation in the probe coil must be taken into consideration. We must set the probe to be in the required parameter. Okay, the size and the shape of probe also can give effect to the result. Okay, and the distance of test coil to the test specimen, or we call it F lift off, can also give effects to the result. Okay, so here are the factors that affecting the eddy current measurement. Okay, the first one, in transducers, lift off. What is lift off? Lift off is separation of the coil from the specimen surface. As the probe is moved uh, from air till it touch the material surface, the impedance of the coil will change. Okay, the second one on the transducers transducer factor is the lift off curve. Okay, surface riding probe or multi-frequency measurement can help reduce this. Okay, this can lift off curve can be used to determine the thickness of non-conductive coating on conducting surface. Okay, the last factor is skin effect. Okay, as the material depth increasing, the eddy current will decrease exponentially. Okay, next, standard depth of penetration. We need to, this also can can affect the result. And skin effect is the limit of sensitivity of eddy current meted to the surface of the conducting specimen. Okay, next. Okay, here is the procedure to conduct ECT. Okay, this is the general procedure on uh, welded specimen testing. Okay, okay. First, we need to connect the probe to the eddy current instrument and switch on the instrument. Look at the picture here. Okay, this is the ECT instrument. Connect the probe here. Okay, then place the probe on the specimen region on specimen on the inspection region on the specimen. Okay, okay. Place the probe on the inspection region here. Okay, there will be a reading on the instrument. Okay, then the reading we need to freeze it. Okay, after that remove and adjust the gain to make the lift off signal appear 100% screen height from a balance point. Okay, okay. To zoom into our example testing here on welded specimen testing, to scan the discontinuities or defect. There are two types for welded specimen testing. Okay, the first one is welded cap and toe. Okay, we need to follow the technique as I show here in this figure. Okay, for the weld cap scanning, we need to do the zigzag motion. Okay, for the toe for the toe scanning, we need to move the probe as the arrow show. Okay, then the the graph will show in the instrument on the screen, and if there is any change in the net impedance of coil or in the graph, that shows that the defect exists. Okay, we need to record the graph, the reading of the graph, then we need to do the root cause analysis, and the severity of the defect also can be determined. Alright.
My name is Muhammad Fauzi. I want to present about advantage and disadvantage for eddy current. Some of the advantages of eddy current inspection include sensitive to small crack and other defects, defect surface and near surface defect. Inspection gives immediate result. Equipment is very portable. Method can be used for much more than flow detection. Minimum part preparation is required. Test produce not need to contact the part. Inspect compare shape and size of conductive material. Okay, for some of the disadvantages of eddy current inspection include only conductive material can be inspected. Surface must be accessible to the probe. Skill and training required is more extensive than other techniques. Surface finish and loudness may interfere. Reference standards need for setup. Depth of penetration is limited, and last flaws such as delimitation that lie parallel to the probe coil within and probe scan direction are undetectable. Thank you.
Photoinductive imaging (PI) is a technique known as photoinductive imaging (PI) was pioneered at CNDE and provide a powerful high-resolution scanning and imaging tool. Microscopic resolution is available using standard size eddy current sensor. Development of probe and instrumentation for photoinductive PI imaging is based on the use of medium power argon ion laser with 5-watt nominal power. This probe provides high-resolution images and has been used to study cracks, wells, and diffusion bond in metallic specimens. The PI technique is being studied as a way to image local stress variation in steel. Pulse eddy current. Research is currently being conducted on the use of a technique called pulse eddy current (PEC) testing. This technique can be used for the detection and quantification of corrosion and cracking in multi-layer aluminum aircraft structure. Pulse eddy current signal consists of a spectrum of frequencies, meaning that because of the skin effect, each pulse signal contains information from a range of depth within a given test specimen. In addition, the pulse signals are very low frequency range which provide excellent depth penetration. Unlike multi-frequency approach, the pulse signal lend themselves to convenient analysis. Optimization of probe design. According to the state of the art, the probability of detection technique of eddy current technique can be improved by the optimizing the probe design. In recent years, several studies have focused on optimization of the ECT probe design for defect detection. Tiago George Rothschild proposed an ECT probe design based on velocity induced eddy current to detect surface defect. Their experimental results confirmed that the proposed probe design was able to detect defect in the conductive material where motion is involved. A bioorthogonal rectangular probe was developed by Zhang. Simulation results show the new bioorthogonal rectangular probe has a lesser effect on the lift-off with higher sensitivity detection. Research by Rosado report the influence of the geometrical parameter of an eddy current planar probe in ECT. The findings showed that modification of the study parameter could substantially improve the probe performance. In this slide, I will talk about related project by industry. For aircraft industry, the general flexibility and accuracy of the eddy current testing method make it very effective for non-destructive testing of aircraft components. ETC allow our technician to scan large area of the aircraft surface, subsurfaces such as wing and fuselage quickly, as well as tight space and complex shaped surfaces. Additionally, ECT is not affected by non-conductive layers as paint and sealant, require minimum part preparation before testing, and does not need direct contact with the part. Other aircraft parts that can be inspected with eddy current include engine blade, propeller, rotor, fastener, and hull. For railway, to solve the task of RCF defect detection, two scanners are implemented in the design of the floor detector. One scanner is designed for the gauge corner checking detection, appear on the gauge surface of the railhead, and the other scanner for the running surface checking appear on the running surface of the area concerned. For automation, in high-volume automotive component manufacturing, eddy current inspection system can be automated and incorporated into the production line. It is typically right after heat treatment. Thank you. For summary, eddy current based methods are interesting owing to the simplicity of machinery integration. Unlike ultrasonic-based method, no coupling is required. Because of the non-contact application, eddy current sensor can be used directly in the process flow without affecting the material properties and quality. Textural analysis and fault testing can be performed at high resolution to document and guarantee the quality of RCF material and finished components. Knowledge of the product quality very early in the value adding chain help to increase the yield of the product process and the safety of the final product. Thank you.